Hi, I'm Varish Varikantham, and my article was titled EMG Activities and Ground Reaction Forces During Fatigued and Non-Fatigued Sprinting. So the purpose and the significance of this research was to investigate change in neuromuscular function and mechanical output during sprinting when athletes are fatigued, and to reform training regimens to prevent injury and improve recovery. Research questions were: how does fatigue during a 400-meter sprint affect neuromuscular function, specifically EMG activity and ground reaction forces? And what are the relative roles of central versus peripheral fatigue during fatigue versus non-fatigue sprinting? Do different leg muscles contribute differently to braking and propulsion phases under fatigue? So for the participants, there were 10 male athletes. Most were 400-meter runners or 400-meter hurdlers, with their record having an average of 51 seconds between all the males, and the height and weight averaged around 1.83 meters and 73 kilograms respectively. Their ages range from 20 to 28 years, and there were no inclusion or exclusion criteria specified, and the study was mainly volunteer based. For the generalizability, the sample is not very representative of female athletes and non-runners, and the small sample size makes the results not very generalizable. And because it was a volunteer basis, more physically active people were likely to volunteer, leading to selection bias. For literature evaluation, the references are directly relevant to the EMG, sprinting mechanics, and fatigue. They provide foundational context for the study design and the measurements, and they're not exhaustive, but they are adequate to support the research questions. For the procedure, for the design, it was a within subjects repeated measures, and the electrodes for the EMG were placed on the gastrocnemius medialis, biceps femoris, vastus lateralis, and rectus femoris muscles. And for the EMG, the bipolar surface electrodes were used with a 20 millimeter spacing on the muscle belly at a sampling rate of 1000 hertz. So the tests were conducted across 2 days, with the first day being a maximal 20-meter speed test, with a flying start over 40 meters with a 400-meter time trial at a maximal effort afterward, to measure both the non-fatigued and fatigued running. And then there's a submaximal 20-meter run with a flying start at the average speed of the first 100 meters of the previous day's 400-meter run for the day 2 test. The maximal and the submaximal 20-meter runs were performed 3 to 5 times, with the 400-meter run only being performed once. And for the measurements, the run times, stride length, and rate were measured by photocells linked to an electronic timer. And the 400-meter interval timing was recorded by the video camera. Blood lactate was measured, as well as ground reaction forces via force plate. Informed consent was obtained, and IRB approval was not mentioned through the article. For the data analysis, the EMG data was analyzed using the CODIS microcomputer system. The non-smooth EMG signals were rectified, integrated, and averaged, and the AEMG was calculated for each muscle separately as an average of the 4 muscles. The average force was calculated by using the integral of the force curve generated from the force plate and dividing by the time for each group. And these were compared between the fatigued and non-fatigued conditions. For the ground reaction forces, the peak and average forces were calculated, as well as the EMG/force ratios. For the statistical test, ANOVA was used to compare fatigue versus non-fatigue conditions for each variable, and as well as the F-test and the correlation test. This was appropriate because the data is a non-parametric data set, and the correlation will allow to see if there is some relationship between the variables. For the results and discussion, for the performance and fatigue aspect, the 400-meter average was 54 seconds with a peak lactate of 17.8 millimolar per liter. The running speed was found to have decreased 19%, mainly from a decrease in stride length as well. The ground reaction forces were higher in the 20-meter sprints versus the end 400 meters. As for the 3 phases of running, there's a braking propulsion phase, and in these phases, there was a 13% decrease in braking and a 10% decrease in propulsion, which indicates that there was reduced force generation and elastic energy use towards the end of the run. As for EMG activity, The GA and BF muscles, the AMG decreased in propulsion. The average EMG decreased in propulsion between the fatigued and non-fatigued groups, but overall the AEMG increased under fatigue, but force still decreased over time, showing that there was compensatory neural activation, and an R value of 0.77 was determined. There was increased leg pre-activation, which was linked to decreased braking force. This indicates that there is stiffness regulation, meaning that if there was pre-activation, there was less force produced because the leg was stiffer over time. And the EMG/force ratio, there was an increase in the ratio, which indicated that there was reduced efficiency over time, meaning that the EMG signals increased and the force decreased over time as the runner became more fatigued, leading to a higher ratio. And this supports peripheral fatigue over central fatigue due to the increase in this ratio. For the significance, there was limitations. There was a small sample size, as I mentioned before, meaning there was limited generalizability. There's only one fatigue protocol, which is the 400-meter sprint, and the ethics and inclusion and exclusion criteria were not really reported. As for the implications, the guides and coaches, it guides coaches and athletes in potential fatigue management and shows link between neuromuscular activity and mechanical output, as well as potentially devising workouts such that athletes are not pushed past fatigue during their workouts, leading to a maximal gain as a result of the workout that they do. For future questions, potential effects on female or recreational athletes could be explored, and different fatigue protocols could be explored as well as long-term adaptations and injury risk under fatigue.